Hi class, welcome to section 6.2. Section 6.2 is going to give you a review of solving linear equations. First thing you have to get familiar with are a couple of the definitions. First thing they're going to talk to you about is terms. Terms are parts that are added or subtracted. So for example, in the expression 4x minus 3y minus 5, there are three terms. The term 4x, the term minus 3y, and the term minus 5. A numerical coefficient, more commonly just called coefficient, is the number part of the term. So if you look at the term 4x, the coefficient is the number in front of the letter, which would be the 4. If you look at the term negative 3y, the negative 3y would be the coefficient. And if you look at the term negative 5, since there is no variable, that's just considered constant. Like terms are terms that have the same letter with the same exponent. So something like 4x and negative 6x would be considered like terms. But 4x and negative 6x squared would not be like terms. Unlike terms can either have different variables like 4y and 2x, or they can have different exponents. The reason this is important is because a lot of times they'll ask us to simplify an expression. There's two steps to simplifying an expression. The first thing you want to do is make sure that all parentheses have been cleared. And then the second step to simplifying is you want to make sure that you've combined all like terms. So if you don't know what a like term is, then that'll be tough to combine them. Combining is just a fancy word that means add. There's several properties that we're going to use throughout this section. The first property is called the distributive property. It just says if you have a number that's on the outside of the parenthesis that you are allowed to distribute it by multiplying everything in the parentheses by that number, and that will clear the parentheses. There are two commutative properties. Commutative properties just means you can change the order of addition or you can change the order of multiplication if it makes it easier for you. And there are two associative properties. Associative properties just means you can change the way that you've grouped the numbers, and that is not going to change your answer. So for example, let's do a couple problems of just combining like terms. So let's say I asked you to combine 8x and 4x. You just add the numbers in the front. 8x and 4x will combine to be 12x. Let's say that I've asked you to combine 7y and negative 5y. Because of the negative sign, that's going to work like a minus, and this will combine to just be 2y. Notice the variable didn't change. Notice the variable did not get an exponent. All you're changing is the number that's in the front. Let's take it up a little notch. Let's say I asked you to combine like terms on x plus 12 minus 3x plus 7. So if you see a plain old x, that's the same thing as a 1x minus a 3x, which would be a negative 2x. And then you can do your constants. 12 and 7 make 19. And that's as simple as you can go. Let's look at the next example. Negative 2y plus 4 minus 6y minus 11 minus 5y plus 3x. I like to go in alphabetical order, so I like to do my x's first. I have a negative 2x and a positive 3x. That is a negative 1x. Then I'm going to do the y's next. Negative 6y and negative 5y make negative 11y. And last I'll do the constants. Positive 4 and negative 11 make negative 7. So your final answer would be negative x minus 11y minus 7. Once you've learned how to simplify expressions, you will then learn how to solve equations. For now, we're just going to solve linear equations. Linear equations are equations of degree 1. So an example of a linear equation would be 2x plus 1 equals 4. Technically, even though they don't write it, the exponent that's on the x is a 1. So those would be called linear equations. Equivalent equations are equations that end up having the same solution. Those would be considered equivalent. Our goal when we go to solve an equation is to isolate the variable. When I ask you to isolate the variable, all I'm asking you to do is to get the variable on one side by itself. It should end up looking like the variable equal to a number. And the number could be any number, depending on the problem. There's going to be four main procedures that you can use when solving. The first one is the addition property of equality. This just says if you have two numbers that are equal, let's just say A is equal to B, then you are allowed to add any number you want as long as you add the same number to both sides of the equation. So if A is equal to B, then A plus C is equal to B plus C. So for example, let's say that X is equal to 2, then X plus 1 is equal to 2 plus 1. So let's use this addition property to solve this equation. I have the equation x minus 9 equals 15. My goal is to isolate the x on the left-hand side all by itself. So I have to get rid of the minus 9. And in general, you want to do the opposite of what you see. So if you see a minus 9, what you're going to do is add 9 to both sides of the equations, which will cancel that away and leave you the x all by itself. And x is going to be equal to 24. And once you get x alone equal to some number, you are done. Another property that you can use is similar to the addition, but it's a subtraction property. If you have two values that are equal to each other, then you are allowed to subtract the same value from each side of the equation, and that will still allow the two equations to be equal to each other. So for example, if I have the equation x plus 11 equals 19, I really want to get my x alone. Unfortunately, it's being added by 11. The opposite of adding is subtracting. So I will subtract 11 from both sides of the equation, and x will equal 8. So you just did the subtraction property of equality. The next property is the multiplication property. The multiplication property says that you are able to multiply both sides of the equation by the same number, and it will keep the equation equal. So for example, if I had the expression or the equation x divided by 4 equals 8, I need to get my x alone. My x is being divided by a 4, so the opposite of dividing is multiplying. And so the divide by 4 and the multiply by 4 reduce each other away, which leaves me the x alone. And so 8 times 4 would end up being 32. The last property is the division property of equality. This just says you're allowed to divide the left-hand side and the right-hand side by the same number, and it will keep the equation balanced. You do have to be careful. You are not allowed to divide by 0. So for example, if you had the equation 7x equals 35, and you were trying to get x alone, because x is being multiplied by 7, you would do the opposite of multiplication, which is division. The multiply by 7 and the divide by 7 reduce away, and x would be equal to 5. So in general, there's a 4-step procedure to solving linear equations. The first thing you want to do is check to see if there's fractions on either side. If there's fractions, you want to eliminate all the fractions by multiplying by the lowest common denominator. Once your fractions have been removed, you want to get rid of any parentheses that are in the problem. The way you're going to get rid of parentheses is by using the distribution property. So remember, that's the one where if you have a number outside of a set of parentheses, you just multiply every number inside of the parentheses by that item, and the parentheses will go away. Next, you'd like to combine like terms. So if you have any like terms on the same side of the equation, you want to combine those to be down to just one number. Last, you'll use your addition or subtraction property to collect all the terms with variables on one side, all of the constants on the other side. You may have to do this more than once. When you should eventually get down to where it is a number times x equals another number. So example, it could look like 2x equals 4. Once you're in that form, you can solve for x using either the division or the multiplication property, and your x will be all alone equal to a number, and you know you will be done. So for example, let's start with one with fractions because that's probably the worst for everybody. So let's say you have the equation 2x divided by 3 plus 1 divided by 3 equals 3 divided by 4. Okay, so we clearly have parentheses on one side, or not parentheses, we clearly have fractions. We want to get rid of the fractions. So to do that, we're going to look at the denominators. Our denominators are 3 and 4. We want to find a common number that 3 and 4 both divide into nicely. The lowest common number in this situation is going to be 12. Another number that would work would be the number 24, although it's not the lowest. Okay, so what we're going to do is we're going to go through and we're going to multiply every single term in this equation by 12. And what that's going to do is it's going to end up canceling your fractions. So the way I approach it is I multiply the tops first. I have a 12 times a 2x, that's a 24x. Then I take 24x and divide it by 3, and that gives me 8x. I'll go to my next term. 1 times 12 is 12. 12 divided by 3 is 4. I'll go to my last term. 3 times 12 is 36. 36 divided by 4 is 9. And so now I have a nice equation that's easily solved. 8x plus 4 equals 9. I am going to do the subtraction property first to minus the 4 away, which will give me 8x equals 5. And I'll do the division property next to get rid of the 8, and which will give me x equals 5/8. I get a fraction as my answer. Does not matter. We do not care. It happens. Just leave the answer as a reduced fraction. Let's look at the next example. 6x plus 8 equals 10x plus 12. Okay, so there are no fractions. That's good. There are no parentheses. That's good. The left-hand side does not have any like terms. The right-hand side does not have any like terms. But you have variables on two sides, so that's a problem. So let's, since the 6x is positive, I'm going to move it by subtracting 6x from both sides. So that's going to leave me an 8 on the left-hand side, and 10x minus 6x is 4x, and I'll have to bring down my 12. Now I need to get rid of the 12, so I'm going to do that with subtraction since it says plus 12. And I'm going to have negative 4 equals 4x. And last, I'm going to use my division property. And that's going to leave me with negative 4 divided by 4. X is negative 1. Okay, sometimes you can run into situations where there actually is no solution. It will be hard to tell until you get down towards the bottom. Okay, but in this situation, there's no fractions, so step 1's done. We do have parentheses, so we'll have to get rid of parentheses with distribution. So I'm going to first distribute the 2 that's on the left-hand side. 2 times x is 2x. 2 times minus 4 is minus 8. I'm going to carry down the plus x, carry down the plus 5, and carry down my equals. I'm going to carry down my 5x, and then I'm going to distribute my minus 2. Be careful with distributing minuses. It will change the signs of everything in the parentheses. So this is going to turn into minus 2x and minus 8. Okay, now we're going to go to the left-hand side of the equation and simplify that as much as we can. We have a 2x plus a 1x. That's a 3x. We have a negative 8 and a positive 5. That is a negative 3. On the right-hand side, we have a 5x minus a 2x. That is a 3x. And I'm going to bring down my minus 8. Now you should start to see that something fishy is going on here because you have 3x on both sides of the equal sign. So when you go to subtract 3x on both sides of the equal sign, all of your variables cancel away, and you're left with a negative 3 equal to a negative 8. Now, that's not good. You're not allowed to have a situation where two numbers are set equal to each other and they really aren't the same. So if you ever run into that situation, that means there's no solution to this problem. There is never a time or a value of x where the left-hand side and the right-hand side are ever going to be equal to each other. This slide just goes over what I just said. Another situation you can run into is you can have infinite solutions. So let me show you what that looks like. So we have the equation 2 times the quantity x plus 4 minus 3 times the quantity x minus 5 equals negative x plus 23. So let's clear our parentheses first. We'll do a 2 times x and a 2 times 4, a negative 3 times x, a negative 3 times a negative 5, notice that's a plus 15, equals negative x plus 23. We will need to combine our like terms on the left-hand side. 2x minus 3x is negative 1x. 8 and 15 combine to be 23. Now you could probably figure it out right here. The left-hand side and the right-hand side are identical, meaning that they will always be equal to each other. So if you run into that situation, that means that the equation has infinite solutions. The left-hand side and the right-hand side are always equal to each other. If it has infinite solution, we call this type of problem an identity, and that all the solutions will be all real numbers. Often you'll end up with like 0 equals 0 or 23 equals 23. If you ever get two numbers equal to each other and they are the exact same number, then you will run into an identity or infinite solutions. Another type of problem you're going to run into in this section is you're going to run into what's called ratios. Ratios, for lack of a better word, just mean fraction. Okay, you don't have to write it as a fraction. If you want, you could write it like 2 to 5. Some people use a colon, 2 colon 5. Some people use the sideways slash like that. I prefer just a traditional old 2 over 5. I think it's less confusing, and that's how you would develop a ratio. If you take two fractions and set them equal to each other, it is called a proportion. So a common one that you'll see is A to B equals C to D. If you are ever asked to solve a proportion, the easiest way to do this is cross multiplication. So you take the numerator A times the denominator B, D. You take the denominator B times the numerator C, and then you would continue to solve for whatever letter you're supposed to. So for example, let's say you have the proportion x plus 2 divided by 5, x plus 5 divided by 8, and I ask you to solve this. So you would first do cross multiplication. We would take the 8 and multiply that to the x plus 2. We would take the 5 and multiply that to the x plus 5. I'm using parentheses because you will be required to distribute the 8. And you will be required to distribute the 5. Once you have your distribution complete, you need to get your x's on the same side. I'm going to move this up a little bit. You're going to have to use your subtraction property. 25 minus 16 is 9. And then your division property. The x value should be 3. Often you'll be asked to solve story problems that involve proportions. When you do this, if there's ever an unknown quantity, you're going to want to use a variable or a letter. So x is usually a common one. When you set up the proportion, you want to list the given ratio on the left-hand side of the equal sign and then list the unknown on the right-hand side of the equal sign. When you set up your proportions, it's important that your units are in the same respective positions. So, for example, if on the left-hand side you put miles on the top, then on the right-hand side you need to put miles on the top. Once you have the proportions set up, you can ignore the units, you can use cross multiplication, and you can solve the equation. Once you go to type in your final answer, make sure that your units are the proper units. So, for example, the cost for water in the city of Tucson, Arizona is $1.75 for 750 gallons of water used. So that's a given ratio. We pay $1.75 to use 750 gallons. That'll go on the left-hand side of our equal sign. The question is, what is the water bill if 30,000 gallons are used? So again, they're asking us how much it's going to cost, so that's our money. So the x will go in the top where the money did in the other fraction. The 30,000 is the amount of gallons. We put gallons in the bottom of the fraction previously, so the gallons will go down there. Now to solve, we're going to cross multiply. We're going to take $1.75 times 30,000. I'll use my calculator to do that real quick. That comes out to be 52,500. And then we'll take 750 times x. Notice I'm completely ignoring the units here. And then to isolate your x, you're going to divide both sides of the equation by 750 because that's the number that's with x, and that's what we're trying to get rid of. So x equals 52,500 divided by 750. So if I pop that in my calculator, that comes out to be $70. $70 it looks like. Okay, good luck on your homework. Let me know if you have any questions.